Today we are on Chapter 9 packet for Chem 1, Worksheet 3, and we are going to be learning how to write formulas for acids and how to name them. So an acid is typically going to start with a hydrogen, and it's going to be attached to something. And that something has a name. That something has a name that either ends in "ide" or "ate" or "ite." And if that's the case, whichever one is the case, we're going to change it to an appropriate acid name. So whatever is highlighted is going to be changing. So the "ide," if it ends in "ide," you're going to change the name to hydro something ic acid. If the name ends in "ate," you're going to change it into something ic acid. And if the ending is "ite," you're going to change it into something us acid. So what we'll do is we'll take a few examples. First of all, we'll do HCl. You've heard of HCl before. You used it earlier in the year with the seashells, and you know it's called hydrochloric acid. But here's how we come up with that name. H plus, because H is a plus, and if we look at a periodic table, you'll see that it's in the first column. So it's going to be a +1 charge when it loses an electron. And it's going to be with chloride, which is Cl minus. So remember, if we put like sodium with chlorine, it would be called sodium chloride. Chloride is the name of the anion of an element, of the element chlorine when it gains electrons. So all the elements that gain electrons are going to now have an "ide" ending. So this is Cl minus is called chloride. So if it's called chloride, you take the stem, which is chlor, and you put it right here, and you're going to call it hydrochloric acid. Okay, let's suppose that we have H plus attached to a polyatomic ion. In this case, it's chlorate, ClO3 minus. And if you look at your polyatomic chart, you'll see that chlorate is right here, and it has a formula of ClO3 minus. So the 8 is going to change into ic. You're going to keep the stem and change 8 into ic. So you're just going to call it chloric acid. No hydro. See, a lot of kids get confused because they think all acids are going to have hydro in the beginning because they all have a hydrogen, but that's not the case. The hydro doesn't mean it has hydrogen. All of the acids are going to have hydrogen in the beginning. It's just the ones that end in "ide" are the ones that have the hydro and the ic. But if it ended in 8, you would just change the ending to ic, and that's it. So this one's called chloric acid. And then lastly, if you have HClO2, hydrogen again is plus, and ClO2 minus is called chlorite. And you'll see that on your polyatomic paper right here, chlorite, ClO2 minus. And so the "ite" changes into us, OUS, and the name is chlorus acid. So that's the difference between hydrochloric acid, chloric acid, and chlorus acid. And if you want a sort of easy way to remember this little pattern, I'll tell you a quick story. One year I was teaching this exact lesson in class, and this is before I made videos, so I was actually going to explain it in class. And it was after lunch, and this girl walks in from lunch with a bag of carrots, and she dropped a carrot on the floor, and then she literally picked it up and ate it right off the floor. And all the kids were like, "Oh, that's disgusting." And I was like, "That's perfect. It actually goes exactly with what we're about to learn." So the little saying is, "I'd hide if I ate something icky and got itis," which sounds like a disease, right? So it's "I'd hide" for hydro if I ate something icky and got itis. So if that helps you, great. If you want to come up with another one, be my guest. That's fine too. So there's a little bit of an exception that we have to talk about that has to do with acids that have either sulfur or phosphorus. So those acids are going to have an extra syllable. So let's say we have H2S. And by the way, this brings up a good point that you can have more than one hydrogen, because this one, remember, hydrogen is +1. Look at sulfur. Sulfur is -2 right here. So because sulfur is -2, it's going to need 2 hydrogens. It doesn't change the name for how many hydrogens you have. Like, it doesn't matter how many hydrogens you have for the name. It just matters for the charges. So anyway, Here's sulfur. It's a -2. Now remember, this would be called sulfide. S-2 is called sulfide. So the ide will go to hydro and ic. But instead of saying hydrosulfic acid, you have to have an extra syllable of UR in there. So sulfur has an extra syllable of UR in any acid that has sulfur in it. So if we take SO4, again, that's -2 on your polyatomic paper. Sulfate is right here, sulfate. So 8 changes into ic. But instead of saying sulfic acid, you say sulfuric acid. There's an extra UR syllable in there. And then the next one is SO3 -2. That one is sulfite. So remember, ite changes into OUS, but instead of saying sulfus acid, you say sulfurous acid. All right, and the same exact thing is going to happen with all the acids with phosphorus. Phosphorus has an extra OR syllable in the acid. So this P is going to need 3 H's because phosphorus is a charge of -3. So you're going to need 3 H's, H pluses to go with that. And that's going to be phosphide. Again, ide goes to hydro and ic, but it's not just hydrophosphic, it's hydrophosphoric acid. Okay, the next one is H plus with phosphate. Phosphate is a polyatomic ion, and the charge for that one is -3. So you're going to need 3 H pluses with that. And phosphate, instead of just going to phosphic, it's phosphoric acid. And then lastly, this one is called phosphite, PO3 -3. So that one, instead of going to phosphus, it's phosphorus acid. So you want to be careful with any acids that have either sulfur or phosphorus. They have an extra syllable of UR or OR. So let's take a couple of practices on the homework worksheet. This is worksheet 14, acids. These are both binary and ternary. So let's take a couple of examples. Let's take number 2. Now we're going to work a little bit backwards. So this one says hydrofluoric acid. So the hydro and the ic came from, remember, the ide ending. So hydro and ic came from ide. So we're going to take the stem and put it together with ide. So this is now going to be, we're going to take the stem, fluor, and we're going to put it with ide. So that's going to be fluoride. So fluoride, you ask yourself, well, what's fluoride? It's just plain old F. And that on the periodic table, you can tell has a -1 charge. So it's going to be F minus, and it's always going to go with H plus. So if you put them together, it has to be just HF. They match up. This is binary because there are 2 elements. And remember, ternary means you have 3 elements. This whole entire worksheet is acids. So this whole column is going to say acid. And that's going to be number 2. Let's go to number 5. Number 5 says nitric. So ic came from 8. Now we're going to look at the stem and put it in front of 8. So here we have nitric. So the stem is NITR, and then we put it together with 8. So it came from nitrate. Nitric came from nitrate. So we look back here and we find nitrate, and nitrate is right there, and it's NO3 -1. So we write NO3 -1. That's always going to go with H pluses for acids, and they match. So it's going to be HNO2. This is a ternary acid because it has 3 elements. And as I said, the whole sheet is acids. Okay, let's do one more. Let's do number 13. Nitrous acid. So we have OUS as an ending. We work backwards and we say OUS came from ite. So we have to look for the stem and put it in front of ite. The stem of the word was NITR. Here's the stem right here. And we're going to put it with ite, because us came from ite. So we look at our polyatomic paper. Nitrite is NO2 minus. So we're going to write that in our anion column, NO2 minus. Again, it's going to be with an H plus because this is an acid. And when you put them together, they match with the charges. So you're just going to write HNO2. And this is a ternary acid because there are 3 elements and acid in that column. So we've done one of each kind on this worksheet, and this should help you to work through any of the other acids that we have on this paper.